Video, we finished talking about the kW of water, and how it doesn't change. So what's the significance of that? Well, let's take a look at our kW and see what it's really telling us, right? So if you remember that kW equals to the concentration of H plus multiplied by the concentration of OH minus, and the product of these is always equal to 10 to the negative 14 molar cubed. So I'm going to keep this equation up here, and let's go back to our definitions of acids and bases. So if you remember that acids were anything that donate protons, and bases were anything that accepts a proton. So if you think about this, if I have an acid, I'm basically donating protons. So if I'm donating protons, that means that my concentration of H plus should be going up. If my concentration of H plus is going up, that means that my concentration of OH minus must go down. The reason being because this right here is constant. So if this goes up, in order to keep this value the same, this must go down. And the same thing for a base. If I'm accepting a proton, what I'm basically doing is I'm reducing this value. I'm making it less. If I'm making this less, what am I doing? What I have to do is I have to increase the OH minus concentration because the kW is always constant. Using the kW, we can do a quantitative treatment of what acids and bases are. So instead of just knowing that it donates a proton and one accepts a proton, we can actually go more in depth and to say at what concentrations does something act as an acid, and what concentration is something acting as a base. So let's take the first case. So the case of an acid. So let's take the case of an acid. So if I'm increasing this H plus concentration right here, right, that means that my H plus is greater than my OH minus concentration. If it's greater than my OH minus concentration, if you really think about it, what's really happening is that there's an acid at work here. The only reason that the H plus will be able to go above the OH minus is if there's an acid at work. And if there's an acid at work, that makes the solution acidic. And I can even quantitatively say that it's not just H plus is greater than OH minus, but H plus is also greater than 10 to the negative 7. The other treatment, or the other way we can look at it, is the basic case. In the basic case, if we look at our equation here, we're accepting protons. That means we're reducing this concentration of H plus. If we're reducing this concentration of H plus, therefore we must be increasing the concentration of the OH. So, in the basic case, the concentration of H plus is less than the concentration of OH minus. And since there's something inside the solution that's accepting a proton, forcing this value, this concentration to go down, and forcing this one up, that means there's a basic compound acting within the solution. And I can again quantitatively say that H plus is less than 10 to the negative 7, means that it's a basic solution. And the last criteria is what we talked about in our first video. In the reaction of water, and this is similar to what's happening in KW, or this is exactly what's happening in KW. So you have where the concentration of the H plus is precisely equal to the concentration of the OH minus. And if you remember, in our equation of water, in our autoionization equation, water was acting as both an acid and a base. So, therefore, it cancels each other out. If you remember our autoionization equation, water was acting as both an acid and a base to create H plus and OH minus. Let me erase this. You don't need the brackets there. So if you remember from our autoionization equation, water was acting as both an acid and a base. So therefore, the solution is neither acidic or basic, and the amount of H plus exactly cancels out the amount of OH minus, and therefore we call the solution neutral. Or we can quantitatively say is that when the H plus concentration is equal to 10 to the negative 7. So when I first, and this all makes sense, but when I first heard about this, I had a really difficult time wrapping my head around the idea that the KW never changed, that somehow it always remained 10 to the negative 4th. And, the first time I heard about this, I probably stayed up 10-15 minutes past my bedtime thinking about why. Why does one have to go down if the other is increased? And so the answer lies in our autoionization equation. So if you look at our autoionization equation, we will find the answer there. So if you see that this system exists in equilibrium meaning that there's some reaction happening on the opposite on one end, and then there's a reaction happening going the other way, and after a while it reaches a point where basically both sides stay the same. And there's this idea that if anything happens to disturb this equilibrium, this whole equation will react in a way that will offset that stress or that disturbance. So if you think about what happens if for example, I increase the H plus concentration. If I increase the H plus concentration, the system is disturbed. And in order to offset that disturbance, what the equation will do is it will start moving towards the left. And once it starts moving towards the left, what it's effectively doing is creating less of OH and more of H2O. So therefore, whenever I increase, so basically the net result is that I've increased my H plus, but as a result I had to decrease OH minus. Well, that does it for that video, and we'll see you in the next episode.